Okay, so today we are going to talk about plate tectonics. You are supposed to be continuing these in your notes. Where is the thing? Turn on laser pointer, exit full screen, turn on. No, I don't. There we go. All right, today we are going to talk about plate tectonics. So you do need to write these in your notes to be used for other things. So go ahead and title this Plate Tectonics. If you look at a map, you'll notice that the pieces fit together. So if you were to cut out the continents, they would fit together. In 1910, Alfred Wegener, I know it's a W, but it makes a V sound, proposed continental drift. This is the hypothesis that Earth's plates are floating on the mantle in a slow and steady motion caused by these convection currents. Pangea is the name given to the single landmass that split and moved apart 200 million years ago to form today's continents. So if you'd like to see a video about that, you can find that on the website as well. So some things that we should take note of is what Pangea is. There were many other continents, supercontinents, but our last one was Pangea. So if you need to continue writing, which you probably do, then please pause this video at this time because I am going to move forward. All right, so let's talk about this. I would pause the video currently and write everything on the screen except for the pictures, obviously, because I am going to talk about them. So pause and write. You may paraphrase as you need, but some evidence for the continental drift in Pangea. The first major thing we have here are landforms. So, back, getting my pen. Landforms, shape of the continental coastlines, the mountain ranges, coal fields, stuff like that. That is an evidence for Pangea having once occurred. So you'll see down in this picture that there is the same mountain ranges on Africa as there is in South America, and they make puzzle-fitting shapes. And we see that all over the world. Fossils, some plant and animal fossils on continents are now separated by water. So we have similar animals in America that are over in Africa or Europe that humans didn't bring over. For example, Australia is almost nearly completely marsupials. Like there's not really any more marsupials in the world except Australia and the American possum. So the fact that we have these similar animals, even though we're so far away, tells us that. Another would be climate, having tropical plant fossils in cold climates. So, for example, in Norway or Antarctica, there's tropical plant fossils, and it's how did they get there? It's not tropical there. But there are also glacier tracks in the rocks in warm climates like Africa, Australia, India, South America. So think about those glaciers as they melted. They would have scooted along because they were on water, and they would have done so very slowly. And as they scooted along, anything trapped in that, like the nut on Ice Age, would be released. And so you find those fossilized in rocks. Another one that we will talk about again another time is magnetic reversal of polarity stripes, and that is on the sea floor. We can see on the sea floor how things have collided and come apart and where the sea floor is actually spreading. And lastly, satellites and sonar data. Sonar data refers to things that are in the Earth, like inside. So we're talking um, earthquake, seismic waves going through the Earth, and we can record that. But also the satellite from space, we can see these changes, these movements, 2 centimeters per year that we see these continents moving around. So if you need to, pause the screen to keep writing. All right, so plate tectonics. This is a definition that you're going to need to know. Plate tectonics refers to the Earth's crust being divided into tectonic plates, which move in various directions. So if you look here, use my mouse. I'm going to use this focus. If you look right here, these little red arrows shows us that Australian plate here, it moves back and forth. And while it's moving back and forth this way, it can move back and forth that way. So it's kind of like it's moving around right here. It can also move back and forth from this way. And so that being said, that it's moving toward this Pacific plate, it's moving away from the Antarctic plate, and it is crashing into the Pacific plate. So that Australian plate includes some of the ocean. And so we're not just moving in one direction, because if we were moving in one direction, we would be moving. So let's see if I have my globe, but I don't see it. We'd be moving in the same direction all the way around the globe, and they wouldn't crash into each other. But that's not the case. These plates are kind of moving sporadically. Okay. 3 types of boundaries. I want you to title this section 3 types of boundaries, and we're going to go over all 3 types. The first being a divergent boundary. It's important to write all of this because what this is telling us is that not only do plates move apart, creating new crust, but there are 2 things that do that, the Rift Valley and a mid-ocean ridge. So as the ocean moves apart, it's not just a giant hole in the ground. It's not an earthquake. What it is it's moving apart and new land is coming in between. And we see that in the very middle of the ocean. That is what a rift valley is. And so this is where the seafloor spreads and makes new land. So our new land is being recycled. So we see that right here. It's moving in. All right, if you would, pause if you need to keep writing, and I'm going to continue on. All right, the second one is a convergent boundary. Again, write it all because a convergent boundary is moving together. These 2 plates have 3 ways. 3, not 2, 3 ways that they could move. Oceanic to oceanic, that just means 2 ocean plates. Oceanic to continental, an ocean plate, and a continental plate. Continental to continental, moving together. And this causes different things, and you will need to write all 3 of these. An oceanic to oceanic will create a subduction, which just means one of them has to go under. And when it does that, it creates volcanic islands, but it also creates these trenches right there, right? So it's causing this crazy trench action. Oceanic to continental, an oceanic crust is going to go under. It's going to subduct under the continental because it is more dense, and dense things sink. And this can create mountains because it's going to push it up and over. And then you have continental, which causes this compression because they're the same type of density. And it's going to push one under and fold up these mountains. So we see different types of mountain ranges in that manner. Please pause the video so you can continue writing, and I am going to move forward. Lastly, we have transform boundary. These are when plates move side to side. So they look like this. The one comes towards me, and they slide right past each other. And this is what causes earthquakes. So basically, we have this friction, and we're going to learn more about that. But when the rocks that are stuck in between them move suddenly, they're being forced to slide past. So just like if you're playing tug of war and they let go, that's what's going to cause that earthquake. Okay, please pause as you need.